Hello, my name is Chris Angstrom from eCapital Advisors. Thank you for joining us for this higher education webinar. My name is Chris Angstrom. I'm the eCapital Data Science Practice Lead. And today we're going to talk about higher education and a little bit about the environment at higher education and how it is a great place to apply some of the data science predictive analytics tools. Just a moment here while I advance the screen. There we go. So we'll talk a little bit about eCapital. So we're an established company with 80 employees with teams in 14 states, 25 million in revenue, 300 plus customers with quite a wide range of services. My area is responsible for advanced analytics, predictive modeling, machine learning, and decision optimization. If we look at, eCapital, the trusted partner to many of these clients of ours. We do have a number of existing clients in the higher education space, as well as plenty in other areas and other industries. To talk a little bit about myself and kind of how eCapital approaches data science. We're very focused on applied data science, and I'll talk about that. So I actually started my career in higher education. I was lucky enough to get a work study job in the Office of Institutional Research, reporting to a PhD statistician who kind of got me started in my career. I started right away coding SPSS and working on a wide variety of projects within the university. So it was a great start to my career. After graduation, I had studied economics, and I started working for a direct marketing company back in the early 90s, building predictive models right out of school. It was a great first job. And did that for a few years, and then Microsoft recruited me out to Seattle in 1993. And I spent 6 years in Seattle and 2 years in London with Microsoft. It was a great time to be there during kind of the pre-internet and kind of the launch of the internet during the 90s. We then moved back to Minneapolis, where eCapital is now based. And I love technology, so I started looking for technology companies, wound up at Medtronic, which is a large medical device company here in Minnesota. Spent 8 years there building various quantitative teams. My last job there was Director of Analytics in what was called the Cardiac Rhythm Disease Management area. After Medtronic, I did analytics consulting for 4 years. And then prior to coming to eCapital Advisors, I spent a year at a med tech startup as the Director of Analytics. When we talk about applied data science, data science is a very large field. There's a lot going on. We are very focused on really applying these tools to the needs of an organization. So, organization understanding and understanding the needs is very important to us, because we want to really select project candidates and build roadmaps that are really focused on, three main things. We have a lot of criteria for project selection, but we're really focused on, first of all, finding a true need. There's lots of information and insight and modeling that can be very instructive and insightful, but very difficult to really measure the impact on the organization. So we really look at projects not in terms of their overall opportunity in terms of ROI to the organization, but then also in terms of how measurable and how deployable are these projects. So there's some techniques and projects that are very measurable in data science, and others that aren't. And it doesn't mean one is lesser than the other, but ideally we want to be focused on things that we can measure and get some momentum in the organization with. And secondly, deployability is probably one of the hardest things in a data science or predictive analytics project. It's one thing to generate insight, build models that are, make sense, are elegant, but if you can't take the information, the scoring outputs, or whatever you may be developing, if you can't integrate that into the existing work stream of the organization, then the project doesn't really reach its full potential, and the value stops at kind of the insight generation level. We're also really focused on team focus. And I'll talk about this kind of later on. Every university or college is in a different spot when it comes to their path down the predictive or data science journey, and really being part of the team, whether you have existing data scientists working already or you're just getting started. We'd love to get in and be part of the team and really help you guys achieve your goals. So I want to talk a little bit about the higher education market, and then we're going to talk about, really focus on how the life cycle approach, looking at student life cycle, is a great framework for developing a roadmap and solutions around data science. And then I'll go into a specific use case around student attrition, and then I'll end with a software demo where I'll actually kind of show you the model building process for a student attrition model, and then wrap up just a little bit with some eCapital information on how to kind of engage with us, or what next steps you might want to take. So it's funny because when I think of higher education, I've worked a lot in healthcare, and healthcare, you tell people who haven't worked in healthcare that when you look behind the curtain in healthcare, it's a pretty gruesome sight. It's a very complex market. There's a lot of distorted economics. It's very complicated, lots of players, governments involved, very complex market. And higher education is also one of those markets, and we'll talk about that. But if we talk about higher education, I mean, I think that, we all started out, the last couple 100,000 years, humans have been hunter-gatherers, and over the last 200 years, I would say, higher education has kind of pulled us out of the, 200,000 years of ignorance to an enlightened stage that we enjoy today and tomorrow. So I would argue that, as Einstein said, compound interest is the most powerful force in the universe, but clearly higher education is the most powerful force in the universe. And when I think of an institution, I think of, it's running an institution or university is like running a small village or a city, because of so many departments and so many areas of the organization that have to work together to achieve the institution's goals. But if we look at the market, we all know that this is a complicated and challenging market. There's a lot going on in higher education. I mean, you have various different kinds of institutions, from 2-year to 4-year to private to public, and you have certainly top schools, top institutions who thrive on eminence and large foundations, and their experience and their growth and things are very different from a lot of the other institutions. And if you look at research and articles and things, you see that most institutions outside of the top tier, most are struggling to attract new students. My daughter, Johanna, just graduated on Monday night, so she and I have spent the last 4 years going through the student, the college application and college search process, and I must say it is one crazy process. I've learned a lot in terms of the application process, and while there have been record applications, students are, with uses of things like the Common App, students are, there's more applications per student. And then if you look at any industry, it's really dealing with, cataclysmic changes in technology and globalization over the last, 10, 15 years and into the future. So, and this is certainly affecting higher education. Most notably, like healthcare, there are a lot of distorted economics in higher ed, from declining flat enrollments, increases in costs and both increases in both costs and tuition, growth rates and tuition costs outpacing healthcare, record student debt. I actually saw it today in an updated figure. It's 1.5 trillion as of May, and university, public institutions looking at declining state budget support over time. And so this creates a lot of challenges in terms of completion rates, attrition costs, fierce competitions for new students. We've all heard about campus facilities arms races to attract students, mergers. And what this does in terms of the operations of institutions, not all but some or many, is that it can create these pernicious cycles where, the whole student-centered kind of life cycle is not being addressed, or being addressed in separate ways, and that it's not a very strategic way of kind of managing these things. So we'll talk about that in terms of a life cycle framework. If you look at the objectives, if you look at institutions that are mission focused, mission centric, and you look at the major departments, they have very, some of their objectives are aligned, others, are less aligned, but there's a lot going on here. And again, this talks about the need for frameworks to really take advantage of these tools, and as well as the complex data environment. Higher education is no different from any other organization that is just struggling to really move their data environment into kind of a modern data platform where the data is accessible to end users, and the data gets where it needs to be so people can use it to improve performance. So if you think about if you kind of boil in a simple way, kind of boil down what does make an institution tick, and I would kind of propose these are some very large gears in what makes an institution tick, in terms of leadership and administration being charged with managing the mission, managing the objectives and growth of the university, the management of it. But if we think about two main things, certainly enrollment planning, just like in a corporation where they have to do workforce planning to really make sure that their workforce is really there to meet the needs of the corporation. Enrollment planning really is kind of the central focus of how the rest of the institution operates and succeeds. And of course, enrollment planning leads directly to resource allocation, which when you're managing a city-like organization is critically important. This drives operations, which essentially drives revenue. So if we think about these two things, specifically around the importance of enrollment planning, this really gives us a context to say, how do we best use these incredible tools that are available in data science and predictive analytics? And we use that with kind of a life cycle framework, which we'll talk about. So if you've ever done work, formal KPI work, key performance indicators, what you'll find is what's called critical success factors. And what that means is, if you have a strategy or a project, you can define what absolutely must happen, for a strategy to be implemented successfully or for a project to be successful. And I think I would argue that enrollment planning is one of the top critical success factors for an institution's success. And if we look at all the stakeholders that really are or probably should be involved in enrollment planning, it really goes across the entire university or college department. And so what we say is, enrollment planning drives or certainly influences so many key activities and outcomes, from revenue planning, which goes to resource allocation and operations planning, moving into marketing and the marketing funnel prospects, to cohort engineering, or essentially as admissions is managing the composition of new student cohorts, to academic planning, student satisfaction, retention, and so on. And so the idea is that enrollment planning is a key driver of so many key activities, and the way to kind of essentially manage these activities is through a life cycle framework. So that's what I want to talk about now. And so when we think about applied data science, in a very simple way, but it's kind of a powerful way of looking at it. It's very simple, but we have data we use to create knowledge or insight, which is great, but the hard part is really transforming that insight into true organizational value that ideally would be measured. And so if we think about applied data science, I said data science is a very large area, but applied data science, we're going to unlock the value. Generally, 4 ways of doing it. Maximizing, first would be maximizing the customer, the employee, or the student life cycle. We'll talk about this. Maximizing operational efficiency. There's a lot that goes into that, specifically if you're familiar with decision optimization, great application in terms of operational efficiencies. reducing risks, uncertainties, and certainly discovering opportunities, patterns. There are some applications where the amount of data is just so enormous or so dimensional that humans really aren't good at analyzing it, and that knowledge discovery or data mining can be used to flag patterns for analysts. But generally, these are the four general areas that we think of in terms of applied data science. Today, we're going to focus on the life cycle, and the beauty of the life cycle is that it really does apply to different constituents or customers, employees, and students, starting with understanding clustering and segmentation of employees, students, customers, valuing segments, asset health monitoring, which essentially say if you have a customer base or a student base or an employee workforce, this is an asset to the organization, and assets have to be managed and they can be valued, and their health can change over time. So is your asset, is it becoming more or less healthy over time? We always develop our customers by upsell, cross-sell. We certainly develop students, and we certainly develop employees as we invest in them in terms of training and experience. And then, of course, retention and acquisition. So if we kind of think about student life cycle, that's student-centric. On the left here, we can see these various stages that students will go through. So there's kind of starting with the marketing funnel from the prospecting for the applicant to the admitted applicant, enrolled, and so on as the student progresses through their educational attainment and engage with the community, with the academic, we create their academic progress. At some point, they either leave the university, transfer, or they complete their degree. They move on to career placements and outcomes, and eventually they become alumni. And alumni, are critical to these two institutions in terms of engaging them and developing them, and really working with them from a giving and donation standpoint. So then, if we think about, if we have a framework that we can reference, we can then start to overlay different analytical and data science solutions that relate to those areas of the life cycle. And the idea is that we can pick certain projects or one-offs, but the idea is that we want to create a roadmap over time where we're doing projects that will kind of reinforce each other, inform each other to make a much more strategic approach to using data science tools in your success. And so we look at different, certain things that run, predicting, can we predict, I know universities have been doing this for a long time, but, predicting enrollment. So students are accepted, but not all of them enroll. So can we predict enrollment? Can we understand their intentions? Cohort scenario modeling, there's some interesting things that have been done over the years in terms of scenario modeling around cohorts, around different techniques like Monte Carlo and things like this, leading to cohort planning and forecasting, engagement, satisfaction, student success modeling, which then can inform admissions and administration. Today we'll talk specifically about student attrition, but then we want to be able to predict students and which kind of alumni segment that they may fall into, because we do want to segment alumni because they do have different needs as an alumni, they have different intents, they have different interests, and if we want to treat them accordingly, and we can value those segments and develop those segments over time. So let's go and talk about student attrition in particular. So I'll talk about a use case, and then what I'll do is, after this, I'll just go into a software demo where I'll actually show you just kind of a simple model building and scoring process. Now, I'll try to wrap this up in 30 minutes or so. I'll do my best. But we are recording this session, so I will send an email after this session, so you will be able to find this webinar on demand or share it with your colleagues or forward it to anyone who else may be interested. So let's talk about, for-year student attrition modeling. Whenever you do an attrition modeling project, whether it's a customer or voluntary employee attrition, student attrition, we always want to essentially start by measuring the cost of attrition. There's a lot, there are plenty of research papers out there on how to calculate student attrition and so on, but generally you'll find different methodologies, and they kind of will talk about direct and indirect costs. So direct costs would be certainly lost revenue, separation costs, just, the actual act of decoupling a student from a university is administrative tasks, paperwork, kind of things. There are vacancy costs, lost room and board, non-tuition fees and things. A transfer or a dropout would certainly affect graduation rate. But then we start thinking about indirect costs, and indirect costs can actually, and opportunity costs can actually amount to higher costs than direct costs. This is certainly true with voluntary employee attrition. But if we think about just the educational continuity of the student, I mean, the student, even if it's a transfer, there is a discontinuity in this person's education, which carries opportunity costs. It also produces education risk if a person does drop out, a non-transfer, and has the intentions of going back but doesn't. And we can think about, all the time that a student is invested just to enroll in the school is enormous. And then the actual money spent and fees and things that they've invested before they dropped is a very large investment on the student standpoint. There's a community impact, so if that student was part of a club, an organization, a community, when that person leaves, that has a negative impact on their friends and colleagues and staff and so on. Reputation impact. Reputation and eminence is certainly an objective of leadership and administration, and most of these admittance rates and graduation rates are public information. And certainly any student who doesn't graduate and become an alumni is the loss of potential future donations to the institution. So kind of starting with understanding the cost of attrition, and in my experience, calculating the cost of attrition using very, very conservative estimates can actually lead to pretty impressive costs that can really get a project moving in an organization and get budget for it. So if we think about, if we decide we want to build a predictive model, we start to think, well, what are the kind of categories of predictive variables we think will correlate with student attrition? And we start to think about things like, well, community engagement. Are they engaging in the college community? I think about there can be certainly financial reasons that derail students. Academic reasons. Are they succeeding? Are they finding a path? Housing and transportation always has its complexities and things that can affect the experience. Then there's, if we think about student experience and satisfaction, I think there is more awareness with students around the fact that they are paying a lot of money, their parents are paying a lot of money, they're taking on debt, and that they are essentially a customer of an institution, and customers, some of them, customers expect a certain level of satisfaction and customer service, and so there may be interactions with non-faculty, just administration or registrar, things like this could negatively impact their experience. And of course, personal reasons are always prevalent in attrition modeling. So typically what we would do is identify different features or predictive candidate variables we would expect to correlate. We would often pre-segment, before we start modeling, we would pre-segment groups. So we're kind of modeling homogeneous groups and build multiple models per group. But we would build a number of predictive models. And it's interesting when I talk to some clients who aren't really necessarily data science people or they're not used to predictive modeling, I often use these two little Venn circles at the bottom to describe what a model, in a very crude way, what a model is doing. So if we look at the random circle, we see there at any point in time a university or institution has active students that are at risk. And there is really not the resources to go and check in on all these students. And so what the model does is it becomes useful by using these predictive variables to essentially concentrate those most at highest at risk at the top of the file. So that's how essentially a model becomes useful. And if we look at a typical what's called the gains chart or ROC curve, in this case, the idea here is that without a model, if we look at the x-axis and we say we have 10% of the student file, and if we go up to the red line, we would expect to find, in 10% of the file, we would expect to find 10% of those students at risk. If we had 20% of the file randomly, we would expect to have 20% of those at risk. But what the model does, and how the model becomes useful, is it concentrates those at risk. And essentially, so in this case, the blue curve represents, at 10% of the file, the model is giving us 31% of the students who have the highest risk scores based on the variables we used in the model. And then if we look at 20%, we can see that 20% of the file now contains 61% of the students highest at risk of dropping out. So this is essentially a way of showing you how the model is useful to administration. And then we would take that information and integrate it with a BI or a dashboard or whatever is being used by management. And the idea here is this is an example dashboard where we have student profile information, risk information based on the model categories used in the model, and then the decision factors, essentially the output scores of the model. And so if we look at, we have a student ID, we could drill in on that student ID to get a kind of a risk profile based on the variables impacting that student. But then we can put in some other student information, what cohort they're in, who their advisor is, and then look at the risk by category. So we could then look at a student and say, these are the risk categories that we defined, and these are the kind of the areas where that particular student is at risk. And if we look at the social risk, we can certainly understand, if a student is not engaging socially in the community, that, it seems plausible that student may be at higher risk than others. We talk about housing. A person who is a commuter student versus off-campus housing versus on-campus housing, we all know that those student experiences and community experiences are very different, and that could indicate risk. And then satisfaction surveys, universities, colleges have a number of ways of capturing student satisfaction in terms of the housing, the faculty, the food, the quality, the transportation options, and so on. And then finally, the decision factors. The model will output the attrition risk, kind of a binary yes or no. Is that person at risk of completing their degree? We also get a kind of a risk level, which is like a propensity factor. And then if we've done we've estimated our cost of attrition, either for the cohort or at the individual level, we can get that. We can add that into this dynamic dashboard. So this is kind of how we would kind of surface the results of the model in a dashboard. And so, taking action, we have our reporting, we have our model, and then that would move into, custom student intervention plans based on the risk area, which would make sense to say, can we get out in front of this? Can we, have set up different programs or certain attention to give to students before they actually transfer or leave. And then lastly, moving back to our life cycle concept, when you build an attrition model, just the data prep and the univariate, multivariate analysis that goes into preparation to model, there's all sorts of insight that comes out of this, and this insight can then be passed on to other areas of the framework to say these can inform these other solutions that we're trying to bolt together in this more strategic data science solution that we all know. Constituents or alumni are critical to an institution, and there are certainly opportunities to apply methods to really get the most out of our alumni engagement as students become alumni as part of their life cycle. From things we've talked about before, from engagement, segmentation, asset health monitoring, retention, development and retention of those constituent segments. So now I'm going to move in, I'm going to transfer over to a demo, and if you'll okay, and I'll share the screen in a moment. I'll get the demo up. Okay, so what we're looking at here is the Workbench. This is a software tool called SPSS, IBM SPSS Modeler. and it's a visual data mining, data science tool. And I'm just going to walk you through a basic kind of model building process, just to give you an idea of how we might go about building a predictive attrition model. And so what we have here, this is our kind of canvas where we're working, and we have 2 Excel files. And the first Excel file is a file of 5,000 previous students who either graduated, transferred, or dropped out. And what we're going to do is just kind of drag a table output onto this, and I'm going to run this, and what it will show us is just show us the kind of a spreadsheet view of this file. And so this file has about just over 5,000 students in it, and what we have, student ID, we have various fields. This is our field this is whether they graduated or attained a 4-year degree or not. This is actually an example from Australia, a higher educational institution. This variable is were they an Australian citizen or an international student. We have housing information, faculty in terms of area of study. ATR is reference kind of entering GPA. Are they an Australian citizen? Various variables we think may be correlated with attrition, whether they applied for financial aid, whether it was awarded, acceptance type, were they early decision or regular. And then we start looking at GPAs across different semesters and different years, cumulative GPAs, changes in these GPAs, housing, and so on. So we start the number of club memberships over different time periods. So we start to see these variables in here that we think may be useful in terms of predicting attrition. So that's how we just kind of quickly look at this file. And then we also have a second file here, which is a recent, which is a student survey file. We can look at that and see the variables coming in based off satisfaction surveys from students. So these are both files that we think contain useful information. We merge them using a merge node. We then use this node here, which is called a type node, which basically allows us to instruct the stream what role each of these variables will play, and they're basically what types of fields they are. So we're building a predictive model. So this is essentially our dependent variable, our binary classifier, and we reference its role as a target, and we're using all other variables as predictors or input variables to the process. Now, typically, this is a simplified process, but typically before we would start modeling, we would kind of do some exploratory data analysis. In this case, there's a node called data audit, and so we're going to drag that onto the canvas. We're going to connect it, and what happens here, we're going to run this data audit. And what happens here is we're creating the stream on the canvas, and what's great about these streams is you can save them, you can replicate them, reuse them, audit them. And so what we have here is every variable, and then we get some just simple kind of descriptive information on them. If it's a binary, we'll get a plot, and it's broken down by whether they graduate or not. Here's our dependent variable. If we have continuous variables, we can see a distribution of this GPA here, and we also get some descriptive statistics. We can look for missing values. We can look for odd values, outliers, and so on. So this is a way of really kind of understanding our data that will help us in our preparation for modeling. So once you feel you understand our data, we're going to start building some models. And typically in a project like this, we may build 20 or 30 models. Each algorithm has kind of its own strengths and weaknesses, and so we always kind of want to find the one that kind of fits our task the best. I'm going to start out with a classification and regression tree. This is a kind of a workhorse of data science, these classification and regression trees. But what we're going to do is drag that modeling node onto the canvas. Our type node is already classified our dependent variable as our grad 4-year variable, and already knows these are our potential predictor variables. So we're going to run this model, and then we'll look at the model and do some basic evaluation of it. So as you can see, the stream is working as the data is pulled through the stream into the different nodes. And this is great visually because you can just kind of have a record where you've been and what you've done. So the model is completed, and this is our modeling nugget. So this is, we pulled this onto the canvas, and we need to connect it to the stream because it has to access the data. So we connect it to the stream, and then we can kind of look at our model. So we're going to open the model up. And the first thing we see here is predictor importance. So we input many variables into this modeling process. And this particular classification and regression tree chose a few variables that it built the model with. And this is essentially a relative importance or contribution to the model of these different variables. And as we can see here, the top two variables involved club memberships at different time in the student's experience. So the number of club memberships. We then look at some other variables, financial aid awarded, GPA, some housing, entering GPA, and so on. So this is giving us an idea of which variables for this algorithm were most meaningful. So if we want to do that, we want to start, there's a lot of ways to evaluate a model, many ways, but I'm going to go through two of them here. One way to evaluate a model is to look at its accuracy. And so we use this node to kind of look at of all the variables, of all the students that the model was given, it was able to correctly classify 90% of these, which sounds pretty good. Now, accuracy, it can be very important in certain modeling situations. In others, it's less important depending on what you're doing. If you're doing anomaly detection where there's very few cases, you may want to use something else for evaluation. But this is a general kind of telling us that the model is doing a pretty good job of identifying those at risk. And so then let's move on, and we're going to kind of look at that gains chart that we talked about in the use case, and we're going to run just a gains graph here and see how the model is how useful it is in terms of isolating those at risk. So this is so here's our gains curve here. As we can see, at 20%, the model is identifying almost 60% of those at risk. At 40%, the model is identifying about 91% of those at risk. So pretty good. The model seems to be doing its job. But we do want to try some other models, so we might go and say, well, let's use the C5 algorithm and see how that performs. And these algorithms there are many options to use. And there are even automated nodes that will try many model types. But we're going to run this other model, and we're going to kind of give a quick comparison. Okay, so our model is completed. We're going to drag our nugget onto the canvas, connect it to our stream, and then take a look. Okay, so if we look at our predictors, see a little bit different shape here. Some, more variables contributing a little bit more than those top two. But again, we see the top two are this club membership at different time points, financial aid applied for, housing, and so on. So many of the same variables in here, a little different approach based on the different algorithms. And just real quick, I want to show you, when we build one of these trees, what it does is, it's hard to see this, but it builds a massive tree. And we can make small trees or big trees, but the idea is that the 5,000 students start up here, and then it selects the most kind of important variable for differentiating on attrition, and it will split the file into various groups, and then keep splitting the tree as it goes down until every single student lands in one of the leaves of the tree. And then the tree determines kind of the accuracy and the model itself. And if you can look at, this is a rather large tree, but you can see how here's our 5,100. It splits on club memberships and goes down from there. What's great about these trees is that they can be used for data prep. You can use them to identify interaction detection between variables to improve kind of feature engineering step. But in the modeling, it's also great because it's very visual and can be used just for exploratory analysis, or for modeling, you can actually describe to management or leadership, what the model is doing. Some cases we don't care what the model is doing, such as in machine learning, but in this case we want to know kind of what's driving our model. So if we're going to select this model, we would now want to, if we have new students or we want to score students every month or week, month or quarter, we'll have a new student file, and that's what this is. Basically, it's what we can do is look at this, and this file basically contains the same information, except there's no dependent variable, so the model doesn't know whether these students, doesn't know anything about these students. But once we run, we bring the model in, and we can score these new students, or score them every week or month or whatever is appropriate, and then it will give us our what it thinks the risk is and the propensity of that risk. So we're just going to connect it to a table again. We'll run this table, or we'll score these new data, and what we see here is the same variables coming through, but if we look at the far right, we'll see these two extra columns saying, does the model, so for these new data, it does not think the student's at risk, or this one, but these students are at risk, and that gives us this propensity score that we can then feed into. So then we can actually drive this straight into many other areas. So we could, run this right into a SQL Server. We could run it into SAS, into Excel, delimited files, and all we would do is connect, and it would write that output to those data sources. So that's our kind of quick demo on creating an attrition model. I'm going to move back just to wrap up here. I'm sorry I'm a bit over our time, but I'm going to wrap up very quickly. Do I need to share there? Bear with me one moment here. Okay, there we go. So I just want to wrap up. I'm a bit over my time here, but I just want to wrap up and talk about kind of how we like to engage clients and any next steps. I mean, we really understand that every university is in a different place with regard to kind of their analytics and data science journey. There are many, many universities that are very advanced in this area. They've got data scientists. They've been doing these things for years. But everyone's in a different place from their capability to their beliefs in these tools, and motivations and barriers. And so when we work with clients or talk to potential clients, we really start to think, like, where are you? What's your readiness? What are you doing already? And how would we best fit in with your team in terms of, if you're already doing work and you just need another team member to come in and work on projects that are being neglected, that's a great role for us. Or if you just don't know where to go, how to start this journey, we can come in as an advisory role to say, here's an assessment of your needs and what you're doing, your data environment, your existing talent, and then here's an assessment and roadmap to get you going on your journey of using these tools to really succeed. So that's kind of our approach. And again, we're really focused on finding projects that really are, we have frameworks and assessments that really help you identify the things that are going to give you the highest probability of succeeding and getting ROI out of these investments. We also do jumpstart assessments, so short engagements with maximum commitment of money and time, where I can come in and really do a full assessment and develop a roadmap for you if you don't really have a project in mind or you're looking where to go. But so I'm sorry that I kind of ran a little long. I was hoping we had time for questions, but I'm going to ask you to connect with me if you do have questions. I'd be really happy to talk with you or correspond over email, or even come out and have a whiteboard session with your team. But thank you again for attending, and I will be sending an email with a link to the on-demand version of this webcast. Thank you again.